Hello everybody, we are in section 11-5 in geometry. We are finding volumes of pyramids and cones today. So I want to remind you about just what a pyramid and cone are, as well as what the altitude of one is. So a pyramid is going to be a 3D solid with one base and lateral faces that meet at a single point. So, and I'll say and triangular lateral faces that meet at one point. A cone is going to be a 3D solid with one base that is circular. So a 3D solid with one base that is circular. Okay. And finally, we've had altitude in nearly every section of this chapter, but I do want to remind you one more time because it is such a fundamental part of this chapter. Altitude is basically height, and it's going to be the perpendicular distance from the base to the vertex. All right. Now, we are finding volume of these shapes today, and the formula for the volumes of pyramids and cones is 1/3 big B times H. And based off of whatever your base is of your pyramid or your cone or whatever, then that is the formula you're going to use for the capital B, meaning base of the pyramid. So with that being said, let's apply that formula in some examples. So in this first example, we're finding volumes of pyramids, and it says find the volume of a square pyramid. So that's letting us know the base is a square with base edges 15 centimeters and an altitude of 22 centimeters. Something that can be helpful is to draw out what this should be looking like. So we're going to have a square base, basically. And then if we connect these all at a point, this does not look the best, but this is basically what we got going on. Here is our square pyramid. And it's going to have base lengths of 15. And then if we were to drop in an altitude, the height is equal to 22. Okay, so we're finding the volume of this. The formula is 1/3 capital B times the height or the altitude of the pyramid. Well, to find the base of the pyramid, this is a square, so we're going to find the area of the bottom, which is length times width or side squared because it's a square. So it's going to be 15 times 15. When we put that into our calculators, we're going to get 225. Okay, 225 is the area of just the bottom. Now we're ready to put this all into our formula. So volume is equal to 1/3 times 225 times the height or the altitude, which is 22. Now, when you're typing this in your calculator, you do have some options. I kind of like to just put 1/3 in a fraction by typing 1 and then the division sign and then a 3. And then I will put it in parentheses just to make sure that I'm keeping that fraction together as a unit. And then I'm gonna multiply that by 225, so times 225, and then times 22. When we hit enter, we get 1,650 cubic centimeters. Okay. Moving on to the next example, we're finding the volume of this square pyramid again. So here, we're still using the same formula, 1/3 capital B base times height. So the base is this square. So that's going to be 16 times 16. And when we take 16 times 16, we get 256. So now this 256 is only the bottom of the pyramid. It's just the base. So we're going to plug all of that into our volume formula now. So volume is equal to 1/3 times 256 times the height. But notice we were not given the height. We've had to work our way around this before in this chapter already. We do have a right triangle here because we were given this lateral slant height, and then we have enough information to figure this out. So this is not an oblique pyramid or anything like that. It's just a right pyramid. So we know the bottom of this is going to be halfway across the square, which is going to be 8. So now we can use the Pythagorean theorem to find that missing side. We know the Pythagorean theorem is a squared plus b squared equals c squared. Well, the c is the 17 and the 8 is one of the legs. H is the other leg. So we could say 8 squared plus h squared is equal to 17 squared. That's 64 plus h squared is equal to, I do not know what 17 squared is, 289. Okay, when we subtract 64 from both sides, we get h squared is 225. Now, h is getting squared. We don't want to divide by 2 to get it alone. We want to square root it. We want to undo the square. So the square root of 225 is going to be 15. So now we know, oh, the height of this pyramid is 15 tall. So the height is 15. So we can plug that in for this value right here. And now we're ready to put this into our calculator. There is more than one way to type it into the calculator, but if that 1/3 is throwing you off, as a reminder, you can just type in 1 divided by 3, and then that's just going to get you your 1/3 fraction. And then we say times 256 times 15, and then I'm getting 1,280 square or cubic meters. Now there is more than one way to type this into your calculator. There's multiple ways that you can use your calculator strategically. So if you have a method that you think might work, but you're not entirely sure if you're getting order of operations right or something like that, you can always ask me in class, and I will make sure that you're not accidentally clicking buttons the wrong way. That's an easy thing to take care of. But if you need something simple, then what I just showed you will work. All right, so these are volumes of some pyramids. We've got one more example of a pyramid, but this time it is a pentagonal pyramid, meaning the base is not a square anymore. The base is going to be a pentagon. A pentagon has 5 sides. So if we were to draw a rough sketch of this, we could draw a pentagon, and I'm no artist, but here is my 5-sided pentagon. And then if we were to connect all of these at a singular point. Okay, that's a little rough. Let me try that again. Okay. The base down here is the pentagon, which is why we're calling it a pentagonal pyramid. Okay. Let's plug in everything that we know. We're told the apothem of the pentagon is going to be 8. So from the center to an edge is 8. And then a side is 11.6. And the altitude from the top to the base is going to be 15. Okay. Volume is still the same basic formula for pyramids and cones. Volume is 1/3 capital B base times the height. And so this base is this whole thing right here, the whole pentagon. So we're not going to use length times width this time because this is not a square. It's a pentagon. So we're going to have to use the formula 1/2 apothem perimeter. Now we do have enough information. So when we plug all of that in, the apothem is 8. The perimeter, if this side is 11.6, it's going to be 11.65 times, which is 58. Okay. When we multiply all of this together, 58 times 8 times 0.5. I'm getting 232. Okay, that 232 is the base value, just as a reminder. This 232 corresponds with this base, only that number. But now we do have enough information to plug everything into our formula to find the volume of the whole pyramid. So we're going to say volume is equal to 1/3 times 232 times the height, which is 15. And when we plug all of that into our calculator, we are going to get 1,160 cubic units. All right. So those are your examples for pyramids. What happens when we want to find areas of cones? Okay. So the formula for the area of a cone is still the same in the sense of it's 1/3 base times height. But the base is not a polygon anymore. It's a circle. So the base is going to be pi r squared when we calculate it. So this says find the volume of the cone, leave your answer in terms of pi. So we're not going to have to round in this one. We're just going to leave it in terms of pi. So big B base is pi r squared. We're told the radius is 16, so we can jump straight into that. Pi times 16 squared is going to be 256 pi. All right. So that is big B base. So now what we can do is take this value, plug it into our formula, because it's our actual base, and we have volume is equal to 1/3 times 256 pi times the height, which is 34. All right. When we do all of that, we are going to get a decimal, but that is okay. I'm going to say if you have 0.33333 repeating, that's technically 1/3. So I'm just going to say what that is with a fraction and pi. So I'm taking 256 times 34 times 1/3, and I'm getting 2,901. 0.3 repeating. Actually, I think I'll write it as the decimal repeating just because that's more common for you guys. And then we're going to tack the pi onto the end because it said leave it in terms of pi. And then we're working in cubic centimeters, my bad. All right. So that is the volume of that cone. Here, we're finding the volume of a cone that has a base diameter of 36 and an altitude of 30. Okay, so once again, volume is 1/3 big B times height, but the base is going to be pi r squared. Now notice this says, what is the volume of a cone that has a base diameter of 36? So if we were to draw this out, because we weren't given a picture of a cone this time, so if you need to draw it, that's okay. The diameter goes all the way across. That's going to be 36. So if we want just half of that, we would need to take 36 divided by 2 to get us 18, because it says the diameter is 36, not the radius. So pay attention to those little details. So with that being said, now we know the radius is 18, so we can plug that into this formula of pi times 18 squared. Okay, 18 squared is 324. So I'm going to leave this in terms of pi for right now and plug this. So this is my base value, but that's only part of my formula. I have to take 1/3 times the base times the height or the altitude of my cone. And so the altitude was 30. I can draw that in here real fast. And let's put that in our formula. So volume is 1/3 times 324 pi times the height, which is 30. All right, when we do that, we're going to get 3,240 pi. And we can just say cubic units. But if we wanted to, so this is in terms of pi, but if we wanted to put it in decimal form, we just say times pi, and that is going to get us 10,178.76 cubic units. All right. We have one more example, and we have an ice cream cone. So something that's really great about 3D solids is that they are all over the place. They are just in architecture, in art, in furniture, all that types of stuff is just all over the world. So this is a really cool chapter for when it comes to real world problems. So it says an ice cream cone is 5 inches tall and has a radius of 1 inch. So if we want, we can just draw that in our picture right here. So we've got 5, and then the radius is 1, and then it says how much ice cream can fit into the cone without overflowing the top. So I know usually, right, there's like this ice cream that comes up and over the top like this. We're gonna say, what if we did not have ice cream doing that and we filled it up exactly to the brim, and then that's all? How much ice cream could it hold? So when we ask how much can something hold or how much can fit inside a shape, we are talking about volume. So we're still going to use 1/3 base times height again for this. Now the base is a circle, so that formula is pi r squared, and we know the radius is 1, so we can go straight into that. Pi times 1 squared is just pi. Now that feels weird, but 1 squared is 1 because it's 1 times 1. And then 1 times pi is pi. So the base value is pi right now. Okay, now we're ready to put that into our formula. Volume is equal to 1/3 times pi and then times the height, which is 5. So we could write this, if we were to multiply all of this out, we could write this as 5/3 pi and then cubic inches if we left it in terms of pi. But if we were like, okay, we want to actually get a rounded answer, then we could take that, multiply it by pi, and get 5.24. So almost 5 1/4 square inches. Almost of ice cream could fit in this cone. All right, so with that being said, those are your volume examples for cones and pyramids. I hope you found this helpful. But of course, if you have questions, I am here to help, and I'm looking forward to seeing you in class soon. Bye.